Okay, this is 8.1 chemistry, very easy. Okay, delta question 1, delta H is positive to 82. If it's positive, يعني أكيد it's endothermic, and if it's endothermic, يعني the products have more energy. If it's positive, that means the products have more energy. And obviously, since it's endothermic and the products have more energy, that means they absorbed energy. They had to absorb energy so that the products have more energy. Whatever. Question 2, what is Hess's law? It only depends on the initial reactants, the final products, and their states, okay? And it is independent of the path followed. That's it. Maybe in the written they say state Hess's law. You'd say any chemical reaction is independent of the path followed. That would be 1 mark. And then you'd say it only depends on the initial reactants, final reactants, and their state. That could come in the written. Question 3. Okay. So look. In the notes, it's somewhere here. This is in the notes. I said this in the AMS recording. Q equals mc delta T, okay, where Q is heat energy, okay, M is the mass of their solution, C is the specific heat capacity which is going to be given. They say it, how they give you the C, they don't say C is 4, they say the amount of heat required to raise the temperature of 1 gram of the substance. That's how they give you the C. And then delta T is just the change in temperature, final temperature minus initial temperature. So in this question here, they say the temperature of 280 grams of water was noted to be 32 degrees Celsius. So the final temperature is 32 degrees Celsius. After they dissolved 8 grams of NaOH, sodium hydroxide. It takes 4 joules to raise the temperature of 1 gram of water by 1 degree Celsius. So that means 4 is our C. Remember, C is whenever they say 1 gram of by 1 degree Celsius, that's our C. Okay, the heat absorbed by water is 6720. Okay, so the heat absorbed, so that they actually gave us Q. You know how the formula is Q equals mc delta T. Q is the heat energy, M is the mass, C is the specific heat capacity, which they gave here, and then delta T is just final temperature minus initial temperature. They want initial temperature. Okay, so let's substitute. They give us the heat, they give us Q, which is 6720, equals the mass. We have 280 grams of water, and we have 8 grams of sodium hydroxide. So obviously the mass will be, if you add them up, 288. It's 288 times C, which is 4, times delta T. Delta T is temperature final minus temperature initial, right? So we could say temperature final minus temperature initial. Okay, and we have our temperature final, which is 32 degrees Celsius. So we can say 288 times 4 times our final temperature is 32 minus temperature initial equals 6720. Then you just divide by this on the other side. Then you get 32 minus, let me divide actually, 6720 divided by 288 divided by 4. You get, I'm going to keep it as a fraction, okay? You're going to get 32 minus time initial. When you divide, you're going to get 35 over 6, okay? So you're going to get time initial equals 35 over 6 minus 32. Or was it 32 minus? Yeah, it was 32 minus, sorry. 32 minus 35 over 6. And you're going to get time initial is, I think it's a repeating decimal. Yeah, you get 26.1666666, blah, 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 blah. So you can just say the answer is 26. Okay. Question 4. I think this one's... okay. Adam. Question 4. This one comes every MS. The bonds, you add up this, then subtract this. Okay, so this one we have 4 CH bonds. So we can just write that as 4 times CH, which is 413. Okay, plus we have a carbon double bond in the middle. So a CC bond, which is 602. Okay, plus we also have the ClCl. Some people in the MS forgot to add this. I remember Yahya came up to me. That's why I got it wrong, because he forgot to add this. Please don't forget to add this. So if you add it, obviously you're gonna get. If you don't add it, you're gonna get it wrong. That would be a silly mistake. Please don't forget to add it. ClCl would be 240 equals. So should equals. Yeah, equals. Once you add this all up, you're gonna get 4 times 413 plus 602 plus 240. You get 2494. It's the same question, I solve every time. And then the products, we have 4 CH bonds again, so 4 times 413 again, plus we have a carbon bond in the middle. This time it's a single bond, so 346. Okay, plus the CCl bonds. We have two CCls. Okay, so 2 times CCl, which is 327. And if you add these, you get 4 times 413 plus 346 plus 2 times 327. 2652. And then obviously subtract the reactants minus the products. 2494 minus 2652, and you get minus 158. They want 4 SF, so you just put the 0.0. Question 5. Okay, this one also it was in the AMS. They give us these two reactions. Okay, I think they're gonna get one of these questions written, and then they want the final reaction. Find the enthalpy change. What's the first thing I always tell you guys to do? Write down your final reaction. So write down NO plus half O2 to produce NO2. Okay, what are the ones we're working with? Okay, we have 2O3. Wait, no, this is not how I told you to do it. No. Sorry. Now you check. No, what? No, how can I write them? Right. You have NO2 in the product, so you have to copy it down. So NO2 is in your product. Over here, NO2 is in my product, and they're both one NO2. Here's also one NO2. So you just copy it down as it is. No need to multiply by anything, right? NO plus O3 to produce NO2 plus O2, and you write delta H equals minus 122. Okay, now we have to do for NO. We already put it down. It came down with the NO2. Okay, so there's no need to do it again for the NO. Now we have to see. We have to figure out something for the oxygen. Remember, oxygen is always the special case, so keep it for last. Now I have to put something that when I subtract it by this one, I get 1 over 2. And x minus 1 equals 1 over 2. And that x is actually 3 over 2. Okay, so in my reaction, I have 3O2. How do I make this 3O2 as 3 over 2O2? I just put it, divide by 2. So I just put it over 2. So what does that mean? That means I divide this whole reaction by 2. Okay, but I also want the O2 to be in the reactants, right? Here the O2 is in the product, so I have to flip it. Okay, so let's flip it. It's going to become 3 over 2 O2 to produce, let me erase this arrow, to produce of 2 over 2 O3, right? I just divide everything by 2. Okay, and since I flipped, it becomes positive. But I also divide by 2, so I have to divide the answer. Divide the energy by 2, so it's going to become 313.5, if I'm not wrong. لا شو 313.5 213.5 قصدي. Yeah, so now you can check 2 over 2 O3 is the same as 1 O3. Where's my eraser? Well, it's the same as saying 1 O3, right? Because 2 over 2. So you can just write it as 1. You don't have to write it 2 over 2. You cancel O3 with O3. 3 over 2 O2 minus 1 O2 is actually 1 over 2 O2. Take that down. We're done with this and this. Okay, then just take the NO down. There's nothing to cancel with it. So NO plus half O2. Draw the arrow. Also, there's nothing to cancel with NO2, so you just take it down. And then check, is this the same as your wanted one? Yes, it is. Now what do? I just add them up. Delta H equals, I add these two up, I get positive 91.5. Question 6. Okay, to change this one also, we solved it for the AMS. The answer in the AMS was negative 150. I got it wrong. I remember I put a different answer. Okay, and in the AMS it was negative 150. To change the temperature of a particular calorimeter and the water it contains by 1 degree Celsius requires 10 kg. So they actually gave us the Q. Okay, they gave us the Q for 1 degree. Okay, because they gave us kilojoules, they gave us the Q, because they didn't say to change by 1 gram by 1. No. They didn't say all that. Okay, they just gave it to you straight. To change the temperature, they said to change the temperature by 1 degree Celsius, 10 kilojoules. That's Q. Unless they say 1 gram, 1 degree Celsius, that's your C. But when they just say energy H like this for 1 degree, that means it's Q. The complete combustion of 8 grams of methane causes the temperature to increase by 2.5. Okay, calculate the heat combustion energy. Okay, they want delta H. Delta H actually equals Q minus Q over N. Okay, please remember the negative sign. Don't forget the negative sign. So that means I need to find this Q. Okay, the Q they gave us is for 1 degree. بس هنا قالوا 2.5 degrees Celsius. So how do you write 1 degree Celsius? It gets me 10 kilojoules, right? How about 2.5 degrees? It's gonna be, what is that bugging? 2.5 degrees Celsius gets me 25 kilojoules. Okay, so my Q is actually 25. So I can put 25 over N. What is N? N is moles, and N equals M over M, right? So the mass they gave me is 8. The molar mass of methane, CH4, is 16. Add it up. I'm not going to add it up for you. It's going to be 0.5. Okay, so 25 over 0.5 gets you negative 50. Okay, question 7. Okay, this one, what is a calorimeter? You use it to measure the heat change. Okay, which one represents a calorimeter? It's this one. In the exam, they might get you this in the written to label the calorimeter. Okay, it's this one here. Okay, these are the sources of direct current. Over here, these two, they get current to the battery down here. Okay, this is the reaction chamber. All the reactions happen down here. This is a stirrer. It's like a fan. It's a stirrer. This is insulation, and it covers it. Okay, this is the water in here. Okay, and obviously this is the thermometer. Okay, and inside here there is a resistance wire. Okay, I'm just showing you this because they could do it and bring it for you in the written because it was an activity in the book to label it. Okay, question 8. H2, okay, blah, 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 blah. They said, what is the sign of delta H here? If the energy is in the products, that means it's exothermic, right? And if it's exothermic, that means the sign is always negative. Okay, and they said if it was 1 mole of HBr, what would the delta H be? Here it's 2 moles, right? So when it's 2 moles, it's negative 72, right? Because here it's in the product, it's negative 72. How about when 1 mole? You cross multiply, you get X equals minus 36. Why is it negative? Because it's exo, huh? Question 9. What is the What's the mass of ethane burned when delta H equals minus 390? Okay, here we have ethane is C2H6. Okay, ethane is C2H6. So this C2H6 is actually, if you find the mass of it, it's 30 molar mass. So in this case, I have 30 and I have minus 1560, right? So 30 minus 1560. 30 grams minus 1560 kilojoules. How about when I have minus 390 kilojoules? I don't know, right? So we're going to put X grams and we're going to cross multiply and you're going to get 7.5, put it to 3 significant figures. That's it. That's all you have to do. RRGR, if you want. You could say that. Question 10. So they said when calcium chloride dissolves in water, the test tube feels hot. Okay, so the test tube feels hot. That means there was some heat energy released, right? Energy released, right? What does that mean? That means it's exo. Okay. When ammonium nitrate dissolves in water, the test tube feels cold. So that means energy was absorbed, right? If it feels cold, that means energy was absorbed, meaning it's endo. So which one is endothermic? It's the second one, the ammonium nitrate one, because the system absorbed some heat from the surrounding that made it cold. However, the exo one is the first one, calcium chloride, CaCl2, because the system released heat. Okay, write the equation of the dissociation of calcium chloride. All you have to CaCl2 gets you Ca2 plus and 2Cl minus. This is from what? Chapter 6. I remember this. Okay, Ca is 2 plus from because it's group 2. Cl is group 7, so it's just minus. So you get Ca 2 plus and then Cl minus, right? Then you have to balance it since you have 2Cl, so you put 2Cl minus. Okay, and then they said use the symbol X to indicate the heat released. Since it's exothermic, that means the energy will be in the products. Okay, if you put X here in the reactants, you're going to get it wrong because it's exothermic. So they want to see the X in the products. Here, they said the dissociation of NH4 and O3. Okay, since we said it's endothermic, that means you put the Y, the energy, they said use Y as energy, put it in the reactants. Okay, and here they put it in the reactants. Now dissociated, NH4 and O3. NH4 is plus and NO3 was minus. This was all from chapter 6. I hope they don't ask a question like this, but you never know, they could still come. Question 11. Calculate the energy change. Okay, you just add these up. Oh my god, this is too much. You add these up, so you have 6 CHs, right? 1, 2, 3, 4, 5, 6. So 6 times CH, which is 413. Okay, plus we have one CC bond in the middle, single, so that's 347. Okay, you also have the ClCl. Please don't forget that. Okay, ClCl is 239. Okay, and this gets you, due to my calculator, 6 times 413 plus 347 plus 239. It's 3064. How about the products? You have 1, 2, 3, 4, 5 CH bonds, so 5 times 413. Plus, you have one carbon single bond in the middle, so which is 347. Plus a CCl bond here, which is 339. Okay, plus you have a HCl bond, so that's 427. And then if you add these up, let me do it 5 times 413 plus 347 plus 339 plus 427. I get 3178. And then if you subtract these two, the initial minus the final, let me see how much do I get. I get minus 114. Yeah, like the answer. It is exothermic. Why? Because the sign is negative, right? And meaning if the sign is negative, yani energy is released, right? If it's exo, it's not absorbed. Question 12. I think there's 13 questions. Okay, what is the molar heat of vaporization of copper if it took 76 kilojoules to change 15.88 grams of copper? Okay, molar heat means 1 mole. Okay, 1 mole of copper is obviously 63.5. So what did they give us? They gave us a 15.88 is 76, right? How about 63.5 grams? Okay, how many kilojoules? This is kilojoules, x kilojoules, right? If you cross multiply, you're gonna get 304, and obviously it's positive. Why is it positive? Because we're going from liquid to gas, and remember, you have solid, liquid, gas, and if you're going to the right, it's endo, meaning it's a positive delta H, right? So if you cross multiply, you're gonna get 304, which is plus 304. Okay. Question 13. Okay, they give us this reaction. They're saying it's endothermic. Why is it exothermic? Because the energy was placed in the reactant site, so it was absorbing energy. Calculate the energy change when 2 moles of N2 react. Here I have 1 mole of N2. So when I have 1 mole of N2, I have 181 kg, right? How about when 2 moles? Put it as x kg. Cross multiply. Obviously, you get positive 362. Positive. Since it's endo, that means it's positive, huh? Okay, how about when 1 mole of NO forms? Here I have 2 moles of NO. When I have 2 moles of NO, we said 181, right? 181 kilojoules. 2 mole. How about 1 mole? Just cross multiply and you're gonna get plus 90.5. That's it for 8.1. Thank you so much for watching, and good luck. I'll post the rest in a bit.